Good morning, everyone. Happy Wednesday to you all. A few quick announcements before we get started. Those of you who have work that needs to get submitted and turned in, start hopping on that. We'll be reaching out to some folks very, very shortly, especially those of you who have D's and F's, to tell you under no certain terms it's time for you to get with the program and whatnot. Remember, these grades count. Tomorrow will, for the most part, be a work day for you. You will have an assignment that will get uploaded, but tomorrow will basically be a work day. There won't be a new video up there, so you'll be using the videos that you already have as you prepare for your quiz coming up on Friday. So you do have a quiz coming up on Friday. With that, today we're going to do the last of the three parts involving an exponential function, and that involves looking at how do we go about graphing it. Now, graphing it will be a little bit more difficult for some of you, given the fact that you may not have graph paper, you may not have access to a printer with which to get graph paper. So I will easily show you how you can make your own graph. It's draw two lines, draw an x-axis and a y-axis, count some tick marks, and then start drawing your graph. You can easily draw out your own graph, so not completing a graph is honestly not acceptable and not an excuse. So today we're going to find key information about the graph of an exponential function and then actually graph an exponential function. So far we looked at how to classify them, how to write an exponential function from a word problem, and how to evaluate them to produce a result. Now we're going to turn our focus to actually doing a graph. So, for our purposes, we're only going to be graphing a general exponential function. So we're not going to graph a natural exponential function, the functions with an E. Those of you who are moving on to pre-calc, you'll be graphing those in a little bit more detail there. So, a general exponential function is y equals a times b to the x. Again, a and b are numbers. Now, for the purposes of graphing, we still have y equals a times b to the x, but now we have a plus k sitting behind it. That k has a function which we will get into shortly. So, as far as analyzing an exponential function, there are 5 parts that we will look at. First off, exponential growth versus exponential decay. So those rules don't stop. So if b is greater than 0, it is growth. I mean, not greater than 0. If b is greater than 1, it is growth. If b is between 0 and 1, that's decay. Do remember those rules are different when it's natural exponential, so make sure you go back to your notes from Monday, refresh your memory on those. Next thing, does the graph open up or down? That is based 100% off of the a value. It is off of the a value. So if a is positive, then the graph opens up. If a is negative, graph opens down. So simple as that. A is positive, graph opens up. A is negative, graph opens down. Horizontal asymptote. So remember, horizontal asymptote when we were doing rational functions is that horizontal dotted line that the graph cannot touch. In the case of an exponential function, that's y equals whatever the k value is. So that's y equals whatever the k value is. So if k is positive, it's a positive number. If k is negative, it's a negative number. You take the number as is. As far as domain goes, domain is very, very simple, very, very easy. All real numbers. All real numbers, or if you use the R symbol, that's fine too. Lastly, with the range, so as far as range is concerned, that's based off of the k value. And it's also depending on whether the graph opens up or down. So if the graph opens up, then the range is y is greater than k. If the graph opens down, then y has to be less than k. So pretty simple, pretty straightforward. So for those of you who are used to using the infinity notation, y is greater than k is the same thing as saying k to positive infinity. And then y is less than k is the same thing as saying negative infinity to k. I personally don't care about that notation. As long as you can do it, y is greater than a number or y is less than a number, then we're good. Then we're good. Especially when it comes to potentially having to type something, type it out. Don't worry about it. So let's look at examples 1 and 2 for literally identifying the parts. So example 1, you have y equals 3 to the x power plus 2. So just so you know, 3 is your b value because it is attached to the variable. So that means for those of you who are wondering, well, where is a in this case would equal 1. If there is no a value, it is understood to be 1. It is not understood to be 0. And the 2 would represent your k value. Now, if there's no k, that's 0. If there's no k, that's 0. So, exponential growth or decay, b is equal to 3. That's greater than 1. So, b equals 3. So, that means this is growth. Graph opens up or down. That's based off of the a value. A is equal to 1. That's positive. So the graph opens up. Horizontal asymptote is based off of the k value. K equals 2. So that means y equals 2 is the horizontal asymptote. So all those are already taken care of. Domain is all real numbers. And your range, since the graph is opening up, your range would be y is greater than 2. And just like that, we've analyzed the graph, we've done all the parts. Analyzed and done all the parts. So let's do one more example, then we'll get into some graphs. Example 2, we have negative 2 times 3/4 raised to the x power minus 1. So a equals negative 2. B in this case is 3/4. And your k value is negative 1. So we do it pretty much the same way that we just did the problem before it. Growth or decay, so b is equal to 3/4. So that would be decay. Because 3/4 is greater than 0, but it's less than 1. Graph opens up or down. A is equal to -2. That's negative, so this graph is opening down. Horizontal asymptote, K is equal to -1. That means your horizontal asymptote is Y equals -1. Domain, remember, is all real numbers. And your range, since the graph opens down, that means your range will be Y is less than -1. Y is less than -1. So, one thing to keep in mind before we start graphing, don't assume that every growth function is going to point up. Don't assume that every decay function is going to point down. You could just as easily have a growth function that points down. You can just as easily have a decay function that points up. So don't assume that because these two examples work the way that they work, that this is how it's always going to work. That's not true. So now let's do some graphs. So as we prepare to do graphs, make sure you have your calculator with you, as I do. Make sure you go ahead and clear out anything that may be in the calculator that may stop you from doing it effectively. So let's get to getting. So for graphing, find the key information, growth, decay, up, down, horizontal asymptote, domain, range. Use a calculator to find at least 2 to 3 points on the graph. Now, of course, if you don't have a calculator, then you got to do it by hand, which is plugging in numbers and doing it out paper and pencil. It is what it is. You have what you have. You work with what you got, or work with what you got. And then we are going to draw the graph using a smooth curve. Draw the graph using a smooth curve. So let's go ahead and start working this out. So example 1, y equals 3 to the x power minus 2. 3 to the x power minus 2. And we're not zooming in just a little bit. So we find all the parts that we did at first. So as far as growth or decay, that's a 3. So this is exponential growth. Let's see, 1 second. Put this back in its right spot. There we go. As far as opening up or down, so A in this case would equal 1. So this is a graph that's going to open up. The K value is -2. So your horizontal asymptote is y equals -2. Your domain is all real numbers. And your range, since the graph opens up, y is greater than -2. So again, I'm going through the explanation of it. That's why it probably is taking a little longer. Most of you all will be able to fly through those 5 parts pretty easily. Now, as far as graphing goes, the first thing that goes on the graph is the horizontal asymptote. First thing that goes on the graph is the horizontal asymptote. Go to your y-axis, find -2, and literally draw your horizontal asymptote. Whether you do it as a dotted line, solid line, I personally don't care, as long as it's there. Now, we need at least 2 to 3 points to put on this graph so we can draw the curve. So this is when the graphing calculator comes in handy. So go to y equals We're going to type in 3 to the x power. So that's 3 arrow, the up arrow to the x power minus 2. 3 to the x power minus 2. So your function when you're using your graphing calculator should look like this. For those of you who are who have an older style calculator, it may look like 3 to the x power. Let's see, erase that. So older style calculators, yours might look like 3, the up arrow, x, and then minus 2. This means the same thing. So again, this is for the older style. This way is for the older style TI-83 black calculators. This is the newer model 84s, things of that nature. So we need points to graph. So hit second, hit graph. We look at our table. We're looking for points that are nice to graph. We're looking for points that are nice to graph. There we go. 0, -1, 1, 1, 2, 7. Those are nice points to graph. So those are the points we're going to graph. Zero, comma, -1, 1, comma, 1, 2, comma, 7. So at least, so somewhere you need to make the table so that I know what numbers you used. Now you can draw the graph. So your curve is going to flirt with the horizontal asymptote and then shoot straight up. And of course, those of you with graphing calculator technology, you can always just hit graph and it will show you exactly what the graph should look like. It can show you exactly what the graph should look like. So just like that, very, very easy graph. Very, very easy graph. All right. Example 2. 3 to the 1/2, 3 times 1/2 to the x power plus 1. Again, we're following pretty much the same things. 1/2 is your b value, so this is exponential decay. 3 is your a value, so this graph is going to point up. Let's see, your horizontal asymptote ends up being y equals 1. Domain, all real numbers. And range, since the graph is opening up, is y is greater than 1. So again, it gets easier to crunch through that once you have an idea as to how everything works. All right, so horizontal asymptote goes on the graph first. Go to y equals 1. Put your dotted or solid line. It doesn't really make a difference. So remember, if you can't access a printer, you can draw your own graph. So there are no excuses for not doing a graph. Now we let our calculator do the rest of the work. 3 to the 1/2 x power plus 1. Go to y equals. We can clear out what we have. 3 parentheses. 1 divided by 2. Close the parentheses. Raised to the x power. And then plus 1. So let's make sure everything matches. So we need some points. Hit second, hit graph. So we're looking for 2 points. 3 points will be beautiful, but 2 will at least get the job done. And it looks like here's the 2 3 points that I can use. Negative 1 comma 7, 0 comma 4. So negative 1 comma 7, 0 comma 4. The last one was 1 comma 2.5, which is not that bad. 0.5s are easy to graph, so graph them. And then you draw your curve. So a decay curve starts from the top and then slopes its way down. Again, you flirt with the horizontal asymptote, but you never touch it. You flirt with that line, but you never touch it. So for my people with the graphing calculators, if you wish to check to make sure that you graphed it correctly, that all you need to do is hit graph, and it'll show you exactly how the graph should look. It'll show you exactly how the graph should look. All right, so we had 2 graphs that were pointing up because the A value was positive. Now we'll do a couple graphs in which the A value is negative, so these graphs should point down. All right, so let's move on to examples 3 and 4. So we have 2 that were pointing up, so let's do 2 that are pointing down to finish off our notes for this section. So now we have negative parentheses 2 to the x power plus 4. So in this case, when you look at this function, there are 2 ways to interpret that function. You can interpret it as it's given, but know that sometimes this might be written as y equals negative 2 to the x plus 4. Now, I want you to be careful here because this is how A, B, and K would be presented. K is easy. That's 4. That's going to stay 4 no matter what. Remember, the B value is the number that is attached to the variable. So that means B is equal to a positive 2. A is equal to negative 1. If B was equal to negative 2, number 1, it can't be equal to negative 2. The B value is not allowed to be negative. So that's point blank, period, for an exponential function. The B value can't be negative anyway. So those are your values. So let's go ahead and get started. B value is 2, so this is exponential growth. The A value is negative, so it's going to open down. The K value is 4, so your horizontal asymptote is y equals 4. Domain is still all real numbers. And your range, since it's now pointing down, y is going to be less than 4. So y is less than 4. So let's go ahead and start with the graph. Horizontal asymptote is y equals 4. Go to your y-axis, solid or dotted line through the number 4. Now we'll let the calculator do some work. So we have negative, parentheses, use the negative symbol, don't use the minus sign. 2, close parentheses, raised to the x power plus 4. Hit second, hit graph. Again, you're looking for 2 to 3 good points to put on this graph. In this case, you luck up, you've got 4 good points, really 5 good points that you can put on this graph. I'm only asking for 2 to 3 so that you can get a good representation of the graph. So 0, 3, 1, 2, 2, 0. 0, 3, 1, 2, 2, 0. Let's see, 3, negative 4 was also on there, so I'm just going to throw it on there. So now you can do your curve. Flirts, and then curves down. So normally exponential growth goes that way and shoots up. So notice that since the A value is negative, it's literally just being flipped over the horizontal asymptote. So it's still exponential growth, but since A was negative, it got flipped over. Let's do one more example to finish this off. Negative 3 parentheses 1/4 to the x power plus 5. Same rules apply. B is equal to 1/4. That's exponential decay. A is negative 3, so this graph is going to point down. The K value is 5, so the horizontal asymptote is y equals 5. Domain is all real numbers. And your range, since the graph is pointing down, is y is less than 5. So again, setting those parts up are pretty much a breeze. Horizontal asymptote goes on the graph first. Go to the y-axis. That goes there first. Now we can let the calculator do the rest of the work. So get rid of this part. So go to y equals, clear. You have negative 3 parentheses 1/4 raised to the x power plus 5. Negative 3, 1/4 to the x power plus 5. Hit second. Hit graph. Again, you're looking for at least 2 points. In this case, it looks like all you're going to be able to get is 2 points. You could plot 1, 4.25. It's not terribly difficult. Negative 1, negative 7, 0, 2. So negative 1, negative 7. Let's see, say that wrong. Guess I did. No, negative 1, negative 7. Zero, 2. 1, 4.25. Be about right there, give or take. So normally, an exponential decay function starts high and comes down low. But since A was negative, it's basically being flipped over. So this is how your curve should look. That's how your curve would look. So again, if you have a graphing calculator, this is pretty easy to work with, but you should be in excellent shape. With today's work, you have a worksheet to complete along with an IXL. So this is your first IXL assignment, so I will be sending you your login so that you can go ahead and complete that. If you have any questions, shoot me an email. Otherwise, I'll talk to you later.